What number is it?
27. 27 on page 358. Do we need more time? Wonderful. Good catch. Yes. Good catch. Good. Good. One more minute then. Yep. Yes. So you bring this down. Write it one more time. You have to bring it down. And then negative 27. Right here. There. Good. So now, x times what is this? You have to put it up. The numerator, the quotient has to have a degree that goes down and down and down. If the first term is x squared, the next one term cannot be x cubed or also x squared, right?
I'm trying to figure out how many x times y equals 6x squared.
It's 6x, right? Ready? Do we need more time? Okay. So x to the third, nothing, nothing, negative 27, and x minus 3. X times what is x squared? X times what is x cubed? Okay, sorry, x squared. So positive x cubed by minus x cubed. How much is x squared times negative 3?
3x.
But I have to change the sign. So positive 3x squared. These two go away. I bring down the next in line. And if you want, negative 27. X times what is 3x squared? Sign? Good. 3x times x is?
3x.
But what do I have to write? 3x times negative 3.
Plus 9x.
So it's negative 9x, but what do I have to write? This is gone. I bring down 9x and then negative 27. Final question. X times what is 9x? Sign, please. 9 times x is? I have to change the sign and I write 9 times negative 3. But what do I have to write?
Plus
What is the remainder of this division?
0.
Good. So then how do I write the answer?
X squared plus 3x plus 9.
Indeed. Any questions? Any questions? Yes, okay, 25. X squared minus 36 divided by x minus 6.
27. Whoops. 25.
Okay, 1 minute. Ready? Back to the handout, please, when you are ready, when you are finished with that. Back to the handout for chapter 6. This handout. Actually, I may need the book, but do we need more time? Okay, ready? Good. Are they in descending order? Is there a missing term from the top?
No.
Good. So then I will have x squared and then negative 36 and then x minus 6. X times what is x squared? When I go back and distribute, I get x squared, but I write, when I go back and distribute, I have negative 6x, but I write,
So 6.
you understand why the space was absolutely needed? Because we could not add unlike terms. So this is gone, and then 6x, and I bring down the next in line. So now final question, x times what is 6x? Sign please. Good. So 6 times x is 6x, but I have to write negative 6x. And 6 times negative 6 is negative 36, but I have to write positive 36. Now, when you read the book, I just want to draw your attention to the way the book presents this, which is slightly different than the way I present it. You choose the method you like. I disagree with what they do because if they don't change the sign, let me see if I can find one quickly. Okay, so what they do, they put minus and then they change it into plus. And then they put plus and they change it into minus and they cross out. So if you read this and you understand it, I'm fine with it. But I think it's more difficult than changing the sign before you write under like terms. So it's up to you. I just wanted to give it a heads up. Okay, so let's start chapter 6. So here is where we are. So I'm expecting you to, between now and Tuesday, to complete this and ask questions in preparation for your homework. And then this is not the way I present this chapter. Okay, so I'm going to present the chapter based on my handout. And then I'll come back to the book and do it one more time based on the problems that they are recommending. Okay? But I disagree again with the order they present the material in. I think it's very confusing. So I think I've been doing this in the last 20 years, and I review this with my next class, and it takes me 2 hours to review the entire chapter, and I'm not kidding. So this is the correct order, and I'll explain everything. Yes, any questions? Okay. Now in chapter 5, we multiplied x plus 1 by x minus 2. And we got x times x is x squared, x times negative 2 is negative 2x, 1 times x is x, and 1 times negative 2 is negative 2. And this is x squared minus x minus 2. Right? This is what we did in this chapter, among other things. But when it comes to a product of two polynomials, this is what basically happened in this chapter, right? This is the okay, let me tell you, we are not doing anything from the book right now. So you can put it. No, I mean, look at my book. It's away from me. I don't need it at this point. Okay, so when we multiply factors and we get a trinomial like this, so we're multiplying two factors and we get a sum or difference of terms, 3 terms, right? In this case, in this example. Well, in this chapter, we are going backwards, meaning we will be given terms and we will come up with factors. So in chapter 5, we were given factors to multiply and get this. In this chapter, we are giving this so we can come up with that. And the reason is, multiple reasons actually, this has not as much applicability as this. And here's one example. When we solve equations, in many cases, we have to factor. So going this way is the distributive law. Going this way is factoring, okay? So from factors, I use the distributive law to get terms. If I have terms, I use factoring to get factors. So basically this was in chapter 5, and this, the second one, is in chapter 6. We solve equations by factoring. We simplify, bless you, rational expressions by factoring. We solve rational equations by factoring. The entire chapter 7 is an application of factoring. Okay, so having 2, 3, or 4 terms and changing them into factors is very useful, and it has a lot of applications. Ready? Okay, so the whole chapter, one more time, deals with factoring and nothing else. And application, solving equations by factoring. There are 3 different polynomials that we will look at. We are going to look at binomials. We will learn how to factor binomials. How many terms does a binomial have? 2. We will learn how to factor trinomials. And we will learn how to factor polynomials. And you could say, wait a minute, what are you talking about polynomials? All these are polynomials. Binomials are also polynomials. Trinomials are also polynomials. True. So I'm going to put in parentheses, not binomials, not trinomials. 4 terms or more. So not binomials, not trinomials. 4 or more terms. Ready? We are going to start with binomials. Okay? So first of all, the strategy of factoring binomials. That's the next title. The strategy of factoring binomials. Step 1. I ask myself, what type of polynomial is it? What is it? And the answer will be binomial. Step number 2. Descending order. Descending order. Step number 3. Negative leading coefficient. Step number 4. Greatest common factor. However, I have to be honest and tell you that these two can be done in one step. Step number 5. Special products. If you go back to your notes from last time, you will remember, you will see, you will find the special products. Okay. So I'm going to list them now. There are 4. We discussed all 3 last time except this one, which is the second one. So, a squared minus b squared, a squared plus b squared, a cubed minus b cubed, a cubed plus b cubed. So this is the strategy for factoring a binomial. If you give me a binomial and you say, factor it completely, this is what goes through my mind. What is it? Okay, it's a binomial. Is it in descending order? If not, I will rearrange it. 3. Does it have a negative leading coefficient? I will factor it out. Does it have a greatest common factor? I will factor that out too. And then I'm asking myself, is a special product applicable here? And I say yes or no. So this is the strategy. Every time you factor, you have to go a binomial. You have to go through these 5 steps. So we'll come back and talk about, or maybe I should talk about those 4 special products right now. Let's do it now. Anyone remembers this? We practiced it a lot last time. And we chose a lot of problems and I said no FOIL anymore. Please don't FOIL. What was this equal to? What 2 binomials squared will give us a squared minus b squared? A plus b
Or A plus B,
times?
A minus B.
Correct. A plus b times a minus b, or a minus b times a plus b, that's fine, the same thing. We did not talk about the second one. So what is the name of the first one? Difference of squares. Excellent. What do you think the name of the second one would be? Right. This is not factorable. To be exact, I should write not factorable using integers, or at least real numbers. But we like to say not factorable. Your book says it's prime. I don't like that, but you can call it prime. Now, what is the third one? Excellent. What is the fourth one? Excellent. No, the sum of cubes. The sum of cubes is factorable. This is the only one that is not factorable. The sum of squares. Good. So can we go back to the lecture? Oh, I didn't even go to the lecture from last time.
So the cubes will be the same as what, 8 plus 2 times 8 minus 2.
Our class was on the first, right?
Yeah.
Say it again, Sylvia, please. I wasn't paying attention.
The cube, the sum of cubes, is that will be the same as the sum of
Nope.
I mean the difference of
Nope. I want to go back right here. So what does the difference of cubes equal to?
9 trinomial.
A binomial times a trinomial. So this is from last time. You have it in your notes. So the binomial is a minus b, and the trinomial is a squared plus ab plus b squared. And I think we talked about the other one as well, but I don't seem to find it here. No, I don't have it. Okay. So is anyone interested in this? Okay, right here. Okay, so what do you think the sum of cubes would be? Exactly.
A plus b
Exactly.
times a squared.
This one becomes negative, and this never changes. This one never changes.
Minus a plus b squared. Yeah, I do have that.
Good. Okay, I'm ready for some examples right now. And I have a list here. So you can put this in if you want on the handout. We just wrote them. And then I have these examples that I would like to go through. Any questions?
So we check the 6 on a review of check 1.
It's completely different. They were going backwards. Completely different. Okay, ready? Here's our first example. 4z squared minus 25. I'm asking myself, what is it? What is the answer? It's a binomial. Then I'm going to ask myself, is it in descending order? Yes. Does it have a negative leading coefficient? No. Does it have a greatest common factor? Do these two terms have a common factor that I could pull in front? No, because 4 and 25 have no common factors. So I'm down to the special products list. There are 4 special products. Only 2 of those have minus. This one has a minus, and this one has minus. Here is my next question in my mind. Can I find something that I square to get this, and something that I square to get this, or something that I cube to get this, and something that I cube to get that? I completely agree with square. What should I put in here in parentheses? What do I square to get 4z squared? What do I get?
2z.
2z. What do I have here? Good. So then, which of these 2 special products will you pick? I know it's a silly question. We already established, but just to make sure.
2z.
This, the difference of squares. If you say the difference of squares, then you will prepare 2 binomials. So please tell me which binomials are ready to go in there.
2z plus 5, 2z minus 5.
That's it. 2z plus 5, 2z minus 5. Excellent. Very good. Any questions? Any questions? Okay, x to the 4th minus 81. First question I'm asking myself, what is it? It's a binomial. Is it in descending order?
No.
Yeah.
Does it have a negative leading coefficient? No. Does it have a common factor, x to the fourth and 81? Is there anything that I can pull in front? No. Now I'm down to special products. Again, I say, well, there are two special products with a negative between the two terms. Now this doesn't have to be factorable. Not all polynomials are factorable. If nothing works, then I'll say it's not factorable. So again, I have the same question. Can I find something that I square or something that I cube to get x to the fourth? The same thing for 81.
Square 9 to 81.
Correct. So I will have 9 here. What will I have here?
X squared.
Good. So then you're telling me that you're choosing the difference of squares. If that's the case, then you will have a binomial and another binomial ready for me.
X squared plus 9.
Correct?
X squared minus 9.
Wonderful. Every time I'm asked to factor, I have to factor completely. And now I am here with x squared plus 9. Is x squared plus 9 factorable? So, is x squared plus 9 factorable? If it's the sum of squares, it's not. If it's the sum of cubes, it is. Which one is it?
Squares.
Right, so it's not factorable. Now what about x squared minus 9?
No.
If it's the sum of squares, then it's factorable. If it's if it's a difference of squares, it's factorable. If it's a difference of cubes, it's factorable.
It can be x plus 3 and x minus 3.
Very good. So then the factored form is x minus 3, x plus 3, x squared plus 9. Any questions here?
Okay.
Why didn't you
Which
go
X
back
minus
to the
three?
special products thing?
But this is not cube. There is nothing that I can cube to get x to the fourth. There is nothing that I can cube to get 81. So this does not work. Only the difference of squares works.
So what's the answer? Did you get that? Okay, now how did you get that?
You told me how to get it.
So why is that?
So this is this, and this is this.
So the sum of squares isn't factorable, but the difference of squares is, so that's why you incorporate x minus 3 and x plus 3.
I applied the same formula that we applied here to get these two. I applied it again here to get these two.
Oh, okay, so I guess when you multiply all 3 zeros together, you can get x to the fourth power minus
Absolutely.
8. Okay.
Guaranteed. Guaranteed.
Can you put up the special complex thing real quickly? I didn't finish copying what it is.
Oh yeah. Next one, y to the third plus 8. I have to go through 5 steps. Number 1, I'm asking myself, what is it? It is a binomial. Is it in descending order? Does it have a negative leading coefficient? Is there a greatest common factor present in both terms that I could pull out? No. So now I'm down to special products. So when I look at the special products, I see 2 of them. If it's a sum of squares, I will write immediately not factorable. But if it's a sum of cubes, I have to get a binomial times a trinomial. So what do you think? Which one would you try? Correct. Correct. So what do you cube to get y, and what do you cube to get 8?
2, 4, 8, up to 8.
So y and 2. So if it's a sum of cubes, once again I have to get a binomial times a trinomial. So what will be the binomial? Remember, let's take a look at the sequence of signs. This is extremely important. If you're factoring the difference of cubes, the binomial has the difference, and the middle term has positive. If you're factoring the sum of cubes, then the binomial has the sum, and the difference is in the middle. So minus minus plus, or plus plus minus. So, ready?
So the first one would be y plus 2.
And I agree.
The second one would be y squared
Yes?
minus
The product of these two.
2y
Very good. Plus?
plus 4.
Exactly. Let's say I have doubts about my work. I want to make sure that I don't make a mistake. How do I check? Absolutely, I distribute. So let's distribute. I want to check. I don't have to. I just want to make sure that I didn't make a mistake. Y times y squared. Y times negative 2y squared. Y times 4. 2 times y squared. 2 times negative 2y. 2 times 4. What will you tell me to do? Correct? Yes?
I'm still trying to get how you got y2 minus 2y plus 4.
Yeah.
Y 2, which means this is y squared, this is 2 and y, and this is 2 squared. So if this is y, then this is y squared.
So basically, we gotta remember these formulas.
Please.
Get these answers. We don't
Please.
just remember
The
right.
sooner, the better. And I have to say this. At the beginning of the semester, I put these formulas on the board, on the paper, and I made a virtual contract with my O12 class. It's what? 2 months later? I still have a few students who ask me, I have no idea how you got that. So please
There's
make
so many formulas to remember. It's like,
no, there are only 5.
'cause
Actually-
then I gotta remember
actually
the
there are-
formulas for the other chapters too. That have formulas. That's
Like which one?
y2 minus y1.
You still have to remember that? You already have remembered that. It's already embedded in here. Just
Yeah, but at
Okay.
the same time,
So
I
please-
still- but at the same time, I can still get something like that, and
well, you will find the energy and the time to do it. For me, please. Okay, next problem. Negative,
So, wait, hold on.
yes?
So for the final, we can't have like a formula sheet.
No, because you're going to sit there and look at the formula sheet instead of working on your exam.
I just need
No,
to
it would
know
help.
so I know the right correct.
We have a month to work on this. In a month, you will dream about it. Trust me.
Yeah, okay.
You will not need anything. Between now and the end of November, you will remember everything. Trust me. Okay, ready? Negative 1 over 16 plus x to the 4th. I'm not even going to trinomials today. I'm only practicing binomials.
Yeah. Anything that
Okay, what is it? What is it?
Binomial.
Good. Is it in descending order?
No.
No. So what will you write?
X to the
Good. Negative leading coefficient? No, the leading coefficient was always positive 1, right? No matter how if we look at from left to right or right to left, it's still 1. Okay, good. Greatest common factor? Greatest common factor of these two terms. So if I have 1 over 16 here, then I will pull out 1 over 16, but I don't have a number in x to the 4th, so I can't have a common factor if I don't have the same thing, right?
Not factorable.
I'm sorry? Yes, I have 1, but I can't factor out 1. It's not going to make any difference.
Except.
So if I have 2x to the fourth minus 2, yes, these two terms have a common factor, which is 2, and I will write x to the fourth minus 1. But 1x to the fourth and minus 1 over 16 don't have a common factor. Is that okay? Would you agree? Which part is not clear? Yes, go ahead.
Nothing. I just don't know where all that just came from.
This one?
Yeah.
It was a question I was answering.
Oh,
So it has nothing to do with what we're doing at this moment. It was just an explanation. Okay. No, it has nothing to do with the top.
So the greatest common factor only applies if there is a leading
If
coefficient.
all terms have that common factor in them.
But only if there's a leading coefficient.
Right, in this case, the leading coefficient is 1, so,
You can't factor because whatever you multiply by 1 is going to be that number.
right. So I can't factor out anything. There's no common factor. Okay. No, I haven't finished.
Oh.
I have 5 questions. I haven't even gotten to the 5th question, right? Okay. So what is it? It's in descending order. That's what I said. We have to be very patient with chapter 6. Very patient. So descending order, negative leading coefficient, no. Greatest common factor,
No.
no. Special product, no. You have to think. You have to think.
The special product is going to be.
First of all, it's a difference. If it's a difference, we only have 2 options for a difference. It's either this difference of squares or it's a difference of cubes.
So.
I agree. Once you say difference of squares, then you will give me 2 binomials.
So we don't need, oh, so we should write what you have down in that box, write that down.
I'm sorry?
So we should write what you have down in that box. The two
Can this be a true statement? That
X squared
Anything-
plus 1/2 x squared minus 1.
No, it's not one.
X squared plus 1/4.
Good. And?
X squared minus 1/4.
Excellent. Is this factorable?
The right one is and the left one is.
So this is a sum of squares, is not factorable. Is this factorable?
Yep. Sure is.
How do I factor that? Is it a difference of squares? I know it's a silly question. Is it a difference of squares or the difference of cubes? Of course, once you say the difference of squares, then you will have 2 binomials ready. Not a binomial and a trinomial.
say if it's the difference of squares.
Yes, if it's a difference of squares, you have 2 binomials. If it's a difference of cubes, then you have a binomial times a trinomial.
So, x x minus.
Yes, that's it. This is it.
And that's the sum of squares? I mean, the difference of squares?
Yes, a squared minus b squared is a minus b, a plus b.
So why didn't we write so it don't matter which one you write, whether you write x minus or x
2
plus
times 3 is 3 times 2. It's not important. 2 times 3 is 3 times 2. So if you write x minus 1/2 times x plus 1/2 is the same with x plus 1/2 times x minus 1/2.
So is it safe to say that any term with an odd number is difference of cubes, and anything with an even number is difference of squares?
Yes, you could say that. However, you have to be able to find the quantity that you cube to get that term.
Okay.
So the answer is yes, but I have to see the problem. Because sometimes, it's a very good question. Sometimes in a particular binomial, I can give you an example in which both the difference of cubes and the difference of squares is applicable. Both of them are applicable. So, ready? Move on. 1/27 minus x to the third is my next problem. We have to go through 5 steps. Step number 1 is, the reason why I put step number 1 in there is because after we finish learning how to factor trinomials and polynomials, we will have 3 different, yes,
I was gonna answer.
yes, please.
Uh,
Nobody was listening to what I was saying at that time anyway, so
Oh.
that's fine.
Well, because you said, what was the next step? So you would put it to negative x, yeah, plus 1 over 27.
Very good. So first of all, it's a binomial. It's not in descending order. Now it is. Now I'm asking myself, does it have a negative leading coefficient?
Yes.
I have to pull out negative 1. So what is left in parentheses? Careful.
Exclusive.
Yes.
Minus
Yes.
1 over 27.
Good. So now I'm down to greatest common factor. There is none. X cubed and 1 over 27 don't have a common factor. So now I'm asking myself, is this the difference of cubes or the difference of squares?
Cubes.
Right. If you say the difference of cubes, then you will have a binomial multiplied by a trinomial. That's the requirement. Once I find the binomial, the trinomial should not be difficult. So what is the binomial? What do I cube? Yes, to
X
get,
cubed
so
minus
it's,
9
so it's,
1 over 9.
so what do I cube to get x cubed? It's x. Then the sequence of signs, minus here, and what in the middle? Plus. Bless you. So then, what do I cube to get 1 over 27?
1 over 3.
1 over 3. So I cube 1/3 to get 1 over 27. And now please dictate the trinomial. Let me remind you how the trinomial is formed.